is resistance is independent of the load, but depends upon the area and relative velocity of the sliding parts, and relative velocity of sliding parts. So, resistance depends upon the area and relative velocity. So, this is area and relative velocity of sliding parts. Light machines like watches, clocks, guns, scientific instruments are provided with this type of lubrication. So, examples are light machine, watches, calculators, electronic instruments, are provided with this type of lubrication. So, we have discussed about hydrodynamic thick film or fluid film lubrication. In this lubrication, a thick layer of lubricant is inserted between two moving parts of a machine. Here friction resistance is independent on the load, but depends upon the area and relative velocity of sliding parts of a surface. So, examples are light machines like watches, calculators, electronic instruments. Okay. So, next is boundary lubrication or thin film lubrication. Next is boundary lubrication, or this is also called thin film lubrication. So, already we have discussed about thick film or hydrodynamic, and here is the contrast of that. Contrast to that is thin film lubrication. Here a thin film of lubricant is inserted in the moving parts. So, here metal to metal contact is possible. Here direct metal to metal contact is possible. This is done when direct metal to metal surfaces contact is there. So, when direct metal to metal contact is there, so boundary lubrication is done. Where thick film fails to persist, where thick film fails to persist. So, this is done when thick film fails to persist, then boundary lubrication is done. Where continuous of lubrication cannot persist, where continuous layer of lubricant cannot persist, then boundary lubrication is done. where a shaft starts moving from rest. Where a shaft starts moving from rest. Okay, there is a heavy load. Where a shaft starts moving from rest. Speed is slow and load is high. Speed is slow and load is high. Okay, so boundary lubrication is done when direct metal to metal contact is possible, and when thick film fails to persist, when continuous layer of lubricants cannot persist, where a shaft starts moving from rest, and when the speed of machine is slow, and when the load on machine is high. So in these conditions we use thin film lubrication, as thick film cannot persist here and the load is high, so we use thin film. So what are the lubricants used in thin film lubricants? So these are vegetables and animals oil. So they have more oiliness, they can stick to the surfaces of a machine. So viscosity of the lubricating oil is very low. Here the oily lubricant is filled between the sliding surfaces, which is absorbed on both the surfaces that are moving. These absorbed lubricants form two thin layer between the sliding surfaces. So they stick to the surfaces. They stick on the surfaces. So these are vegetables and animal oil. So the lubricant used in fluid film lubrication is the lubricant used in thin film lubrication is vegetables and animals oil. Why these are used? Because they stick to the surfaces where the metal to metal contact is possible. So they have a long chain of hydrocarbons. Long chain of hydrocarbon. For example, there is carbon number maybe fatty acid chain. So more than 3, 9, 10, 11. So the long chain fatty acids are there. So surface is reduced. A thin lubricant should have high viscosity index, a good resistance to heat and oxidation. High viscosity index. So high viscosity index means they should not change its structure with increasing temperature, or the viscosity of the lubricant should not change. Good resistance to heat and oxidation. So they should have good resistance to heat and oxidation. So good resistance to heat and oxidation. So they should have good oiliness. Good oiliness. Okay. And they have low power point. Low power point. So what is power point? Power point is the minimum temperature at which the oil ceases to flow. So minimum temperature at which the oil ceases to flow. So next and the last is extreme pressure lubrication. That is extreme pressure lubrication. Third one is extreme pressure lubrication. So this type of lubrication is done when for the fast moving machines, where thick film or thin film lubrication is not possible. Because in these conditions temperature of a machine is increased. Temperature of machine becomes high. Becomes very high. So when the temperature of machine become very high, when the thick film lubrication or thin film lubrication is not possible, fast moving machines. So when these type of conditions are there, so we use extreme pressure lubricant lubrication. The fast moving or sliding metallic surfaces under very high pressure produce a large amount of heat, so the temperature become very high. The ordinary liquid lubricants cannot persist here or even vaporize at such temperature and fails to stick over the metallic surfaces. So extreme pressure additives are added to the mineral oil. So what are the extreme pressure additives? So the extreme pressure additives are chlorides, sulfides and phosphorus. These are the groups with hydrocarbon chain. These compound react with metallic surface at high temperature to form metallic chlorides. In these additives like chlorine, sulfur, phosphorus are added to lubricants. These additives at high temperature becomes chlorides, sulfides and phosphides. So at high temperature the chlorine becomes chlorides, sulfur becomes sulfides and phosphorus become phosphides, and they stick to the metal surfaces and make the lubricant stick to the surfaces. So that's all.